From the tests at the racetrack, I got some very good suggestions to improve usability. Today I will show you how I implemented them. When I'm suggesting maker projects, I want them to work perfectly. That's why I'm publishing updates for my projects sometimes. On the hardware, I like to test the limits within it can actually be used, because I want to avoid the project being a flop. With the infrared sensors, I wasn't quite sure whether they would really be suitable for the purpose. That's why I did extensive tests, which I presented in a previous video. While developing the code, I like to run tests with simulations. Once the code is running correctly, I start practical testing. In this project, I got a lot of feedback from slot car pilots. This is particularly valuable because in this way we can further develop the project together. Our lap counter has quite a number of features on top of lap counting. Practical tests were starting the race, stop it, interrupt and continue the race, as well as checking the lap times and all other timers. From this you get a good feeling for the usability. This experience was showing us that you can actually control the race via the browser interface. In addition, all of the interesting data from the race is presented very well. The pilots can track the number of laps on a tablet or a computer screen and see the best lap times, differences, etc. Spectators can follow the race in all its details on their smartphones. And they are amazed from the incredible dynamics because they see the voltage on the power rails on their smartphones, which shows them when pilots accelerate and brake. A third person can actually control the race using the browser interface. However, it is difficult for the pilots to quickly trigger the stop function on the browser interface of a smartphone, tablet or computer in the hectic pace of the race. So it became clear that a red hardware stop button is needed that looks something like a panic button or an emergency stop. So it would be best to have that button big, sturdy and easy to trigger. The pilot presses the button to stop the race when his slot car has jumped off the racetrack. The effect is just the same as with the stop function on the browser interface. All timers are then on hold. Using the browser controls, you can experience some milliseconds delay from the Wi-Fi network. In the case of the hardware button, the delay is practically zero. It makes sense to have the green start button as hardware too, simply because it makes it more convenient for the pilots to continue the race. For the blue reset button, we had a lot of discussions before we decided to have it in hardware. Yes, it is more convenient for the pilots to reset the race using a hardware button. However, it would be totally annoying if this happened by mistake. That's why the reset button has got a protective ring in our housing design. The ring prevents you from accidentally pressing the reset button because you might have confused it with the start button. Now I would like to briefly show you the implementation. In the code, I use the variable start-stop-res to control the timers, the relays and the traffic lights. If this variable is equal to 1, then the lap counter runs. If the variable is equal to 0, then it stops, and if the variable is equal to -1, then the counter is reset. Now we actually only have to connect the 3 buttons to digital inputs of our ESP32 board and query the inputs with a subprogram. When the button is pressed, we assign the corresponding value to that variable. Of course, we have to define the pin numbers. What we are doing here, we are 3 integer variables in the code. And then we have to define the pins as inputs and activate an internal pull-up resistor so that the inputs are high as long as our hardware buttons are not pushed. We define this in the setup using these commands. When the button is pressed, the input is pulled too low. We are processing this in the subprogram mentioned. Here we query the buttons and we apply a certain logic to prevent a reset during the race, for example. In addition, we also prevent multiple triggering, which could be caused by switch bouncing. With the pin assignment, you shouldn't make the same mistake as me. I chose the wrong inputs in my first attempt. Some of the pins actually do not have an internal pull-up resistor. In case you use these, you are wondering why it doesn't work. For the case you would like to extend the project, here's the list that shows which inputs are having an internal pull-up resistor and which do not. I share this list here because this information is not that easy to find. Complementing the circuit is then relatively easy. You just need to connect the button to the appropriate pin and to ground. Just as a side note, the setting for the number of racing laps is also controlled via the variable mentioned before. In theory, you could apply the same principle to set the number of racing laps using hardware buttons. But we found that for these settings the browser interface always has an advantage. The features of the lap counter remained the same. We only improved the usability. You can use the hardware buttons and the browser interface in any combination to control the race. Testing is always worth it. Usability also needs to be tested if you want to improve it. Ultimately, we want to produce maximum fun with our lap counter and not the opposite. With a few additions, we actually achieved that. During the numerous tests, I realized that I need to give a number of tips for the overall circuit diagram. I will come up with a separate video explaining the overall concept. And later I want to show you how you can record and evaluate a race on your PC. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.